Hello everybody, it's Crazy Logics 007 on YouTube, Crazy Logics in the forum, and everybody else just calls me Damon. Um, I think I got my cameras set up here. We can go to the scope up in the corner, there we go. So we got the CT Sounds here. We had fixed the power supply. Off camera, I had rebuilt the driver card, which everything tested okay on it. I just replaced the two chips. They are, let's see if I can find my part number. I guess I don't have it written up there. They're the 2147s or 44s, 40. I think that's right. IRS 21844s is what they are. Yeah. So, anywho's, let's go over a couple things. In the last video, we had tested the voltages before I'd soldered this back in. So let's go ahead. You're going to see, let's see if I can, up here you'll see my power supply. And you'll see it set at like 13.8 volts. You'll see it's already drawing 1.74 milliamps of current. That's the backup power to the radio I have on my workbench. So that would be like the yellow wire, the memory wire. So it already pulls a little. I need to hook me up a toggle switch to cut that piece out whenever I'm doing some of this, so I can have a little bit better stuff. But right here in the corner, going all the way over here, is a little LED. We're going to power this thing up. You'll watch my power supply max out a few times, and that's the light that's maxing. Tells that we're maxed out, but it settles down to about 1.5 amps when you take out the other. And then I've got my multimeter here, and if I can get it on the screen, it's on 200 volts, and I'm going to go the center tap piece of all these transformers. There happens to be a nice place on this board where I can get it. And so the high side is these 5 FETs on each side. The low side is these 5 FETs on each side. So the high side should have positive voltage in the middle, and we're at 88.4. And the low side should have negative over on the source leg, which is the third leg, negative 88. And I've checked all those to make sure I got good voltage there. Now we should be producing low side drive pulses. So I got my multimeter, or my oscilloscope, I've got it set here, and we're going to check the gate on the low side, and bam, you can see right here we got the low side. Now I have my scope in AC mode, and when I flip it to DC, you're going to see those pulses go totally away. And that's because all of a sudden those pulses are actually riding on that low voltage. So I gotta switch my scope probe to 10 times to be able to go down to that low voltage, and now you see those little bitty pulses riding down there on the low side. I wonder if I can, nope, can't turn it there. So there's low side drive. So we're going to check every one of those, and I don't think I had to replace any resistors on the 5 here, on any of the FET drives. And so always check all of them to make sure. But if you're producing low side drive, you should be able to put 1 FET in each bank. And so we got a bank here, bank here, bank here, and a bank here. So you get the high side banks and the low side. And so I'm going to let off the power there. You see my power supply drop back out. And so the thing we have to watch out for is voltage on the rails. Now it's not going to drop very quick. We don't have any FETs in it, so it doesn't help complete the circuit. And this might have one pull down resistor there. I think we talked about this in the video, you know, being really careful. And so we're already down to 30 some odd volts. That's good. It's dropping. If you leave your meter on it, it actually helps drop it a little bit faster. And then I've got my notorious little zapper that I like to hold, you know, here and zap myself. So I could go 1, 2, 3, 4, 5. That's the 5th one to there. And that should burn it down really well. So let's double check. About 0.4 there, and about 1 point there. Oh, how do you do it to the thing? So there we go. We're about 2 volts. I'll probably pull it down a little more. About 0.5. Oh, and we need to turn the power supply off, and we should be good. We will drain. So the filter caps up here for the input filtering for the power supply, you can drain those just by going across the positive and negative there. Not a big deal, but I don't like having anything that, you know, some of these amps have quite a few caps there and can build up quite the little charge. So we need to find some FETs somewhere around here. Give me just a moment and I will find. We need 20 FETs. Holy canoodles, a lot of FETs. Alright, we got a case of 640s. This is a whole stick of 50, all date coat matched. If you buy them in quantity, it helps because then you get all the same date and they can all match up. So get the plastic bit out of here. It's fighting me. There's my pliers. Oops, that broke. Not very solid. There we go. Alright. 2, 4, 5, 6, 7, 8, 9, 10. One side. There's the other side. Okay, fire up the soldering iron. Let's change this. Get rid of that for a minute. So we need one here, one here, one here, and one here. And so what I'm going to do is place one there. 3, 4, 5. Should be first one on the high side. On each side. And I use my little stick here. I'll kind of go off this FET. Make sure I get the height right. First getting these couple in. Oh, let's see here. They don't have to be perfect, but sure helps if they're pretty close. You can do that. You can do a paper trick where you've drawn the height of it there and set it that way. All kinds of different ways to do it. Some guys make little jigs and set the height at first, and then they can just use it to push them all there. Just all depends. Figure out what works for you and do it. But then I will solder in just ever so slightly from the top here. The gate, because it's always the easiest to solder, and I'll just put a drop, just enough to hold it in place. My bald head out of the way. Make sure you're in good position. You can flip the board over and then actually solder them in real good from the bottom. Boost here on my soldering iron. And then finally go back and hit the gate again from the bottom. Get our solder back out of the way. We put our meter back on continuity. So that it would beep. We test. Make sure we didn't make a solder bridge. I don't know how important that is to keep repeating. Biggest mistake you'll make when you first start trying to fix something or replace FETs, anything you ever do, is you'll make solder bridges, especially if you are not really good at soldering or not using plenty of flux and stuff like that. You know, as you get more skillful at it and you get more time under your belt, you'll get better at it, but it's still super duper important. And so we need to get our scope probe. And I'm going to turn our power supply back on. You're going to We'll see that. We've still got it in 10 times mode, and it's DC coupled. We may have to switch it to AC. It's going to charge up. Let's see. Voltage is falling, current's falling back down, and the green light's staying on. We have on the low side, the drive frequency is increased. Can you see that? If I switch it to AC, you can see that a little better. I'm going to let off of it, and we're going to wait a second here. We're going to feel each of these fits. Don't do them both thing, you will zap yourself. But we're feeling the back of them for heat. That looked good. We're going to check this side's low side drive. That came up. You can see that. Let me increase the intensity just a little. And then we should be able to so there is the high side on the source leg, and that means it's got a good pattern. So technically we can test this amp now. So I'm gonna let it set for a second. We didn't get hot there. Always check your plus or minus 15 volt regulators. They like to get really hot if they're not clamped to a heat sink. I've got just some cheap Harbor Freight clamps and a couple of sticks of aluminum that I use sometimes. Will be aluminum bars. One of them on one side I put Kapton tape, so that if like these regulators are the fully enclosed in plastic style, but some of them are metal tab like this, and you can't bridge that with raw aluminum. So one side I got Kapton tape. I don't know where my little aluminum bar is, or I'd show it to you. I'll show it to you in a video, another video. But you can clip that on with a little clamp and help dissipate some of that heat. If they're bare back, then you use the side with the Kapton tape. If they're enclosed like this, you can just clamp it on to help dump a little stuff. I'm gonna have to get a drink here. I kind of got the hiccups. Okay, so technically we should be able to come over here with an input signal, and I'm going to look at this stuff and turn the gain down. I'm going to make sure we'll work it back and forth a little bit here. We're going to turn the gain to halfway, right in the middle, because we'll leave the volume low on the stereo. Subsonic we will turn way down. The low pass filter, I always try to set it at about 100 to 120 for testing, not for playing in my car. So I'm just going off the end plate here. And 0 bass boost. I always work the pots back and forth. We'll clean them before the amp gets put back final together with a deoxit. I've got that turned all the way down. And I got my speaker wires here I can hold on there. So I can fire up, and you're going to see the amperage jump. My radio. Got a little USB stick that's got some copyright-free music. And when we fire up this amp, my radio is just going to go crazy wonk. So the amp pulls more current with outputs in it than it does just the power supply itself idling. So I'm going to hold the speakers on there. That's it. We're done with that part of the test. It played a little audio. I don't want to get it enough to make these hot. We're going to shut off the power supply. unplug this. We're going to let the rail volt. Now let's look at the rail voltage and see if now that we have FETs in, if it drops a whole lot faster. Let's just take a peek at that. That'd be a good thing to show. So probe that point, and we're still at 36 volts. You guys can't see crap. So it still doesn't drop down super fast, but it's dropping down pretty good. So this would be the rail to rail, the high side and low side, the positive and negative rail we're going here. It's the drain on the high side and the source on the low side. And so it's going down slowly. Alright. If there's a lot of background noise, sorry, it's winter. And so I've got my little fan heater running, and I got the propane tank because it's blowing, snowing outside, and it's windy bad, and my little bitty garage here is kind of not perfectly insulated and a little leaky, so you gotta have a little heat or else I'd freeze. So we're gonna take a quick break. To you guys, it'll be instant, but I'll go ahead and solder in. Well, you can't even see them there. The rest of those FETs. I will clean these pots. I don't think I need to show, you know, putting thermal compound on the backs of everything and getting it in the case and everything, but since it worked with those, I'll put those in. I'll probably test it for 2 seconds, just like we did now, to make sure that the audio looks clean coming out with my scope. But I'll go ahead and get it into the heat sink real quick, and then we'll do a little more testing, and we'll fire up the medium-sized power supply, and I'll talk about power supplies for a minute when we get back. Okay, we got the amp back in the heatsink. I've got it hooked up, RCAs, and some power over here and stuff. And now I've got it hooked to my 22 amp power supply, which you know, this little power supply is just 3 amps, perfect for testing. Things can't blow up very often because it limits the current so much. Once I've tested with that little one, then I'm happy that this one or that the amp is functional. I'll switch it over to my 22 amp power supply. This is where that's the power supply. It'll actually test small amps, you know, a little bitty like punch 45s. But I'll crank up every amp on this one for sound quality testing to make sure everything's functioning properly, check all the gains, make sure, or check all the pots over here and stuff to make sure that they're not scratchy, all that kind of stuff. And so we're going to fire up the amp, and I've got a 60 hertz test tone. There we go. You guys should be able to hear that. And let's see it on the scope. And there it is, and it looks nice and clean. The camera may not pick that up perfect because of the frames per second, I don't know, but it looks nice and clean to me. So let's switch to some music. Let's see some bass. It's going to take it a second. Looks like it's about a 45 maybe hertz. See it dancing around there. And you can hear it. And that's what music looks like. Bass music anyway, because this is sub amp. So I will run it up on this, on the 60 hertz test tone, up to the full power of my little power supply. And I'll play with, like I said, I'll play with all the knobs down here at the end. So get him in the picture there a little. There we go. All the knobs, and I'll go through all those and make sure there's nothing in that they get cleaned up real good. Test a couple other frequencies and just run it as max as what that one will do, listening for sound quality, and that's all I do on my little supply. Then I take it and I hook it. I've got a 75 amp charger hooked to two big monster North Star batteries that I run in on my big cables, and I'll put my big fuse in and I'll hook it to my big load bank, which is 4,000 watt 4 ohm resistors clamped between two giant heat sinks, and I will crank it up as much as my setup will let it go, which is about 120 amps, depending on the thing. I'll monitor it for clipping and stuff, and then I'll just let it cook and get good and hot, and make sure that nothing is weak and nothing blows, and then the amp's done. I'll test it for a little sound quality again real quick and call it good. But I run a sine wave into it and I run it into that 4 ohm load bank because nobody wants to hear this big loud amp coming out of my garage through subwoofers in the middle of the night. So that's what the resistive cells are awesome for. You can just cook the amp real good and make sure it's not gonna, something's not weak, but it does it nice and quiet. And so anyway, that's this repair. It's a little dirty and beat up. Whoever owned it dinged it up and let it slide around a little, but we'll wipe her down. And they don't have the other end cap, so I'm assuming they were messing with that a lot. But anyway, yeah, CT Sounds 750, or sorry, not 750, I'm all upside down here, T2500.1D. Hope you had fun with my fumbling around and stuff on this, but I appreciate you guys subscribing. I've got a lot of subscribers now. Numbers growing all the time. It's crazy. I appreciate it, and I want to say thanks, and keep commenting. I try to get to the comments when I can, and like, subscribe, all that YouTube stuff, and thanks for watching. See you next time.